Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile-long superconducting magnet ring and the largest, most powerful particle accelerator in existence. It represents humanity's pinnacle of scientific accomplishment. In fact, it is powerful enough to recreate the conditions at the beginning of the universe. But could this groundbreaking device unlock the key to the universe's secrets, or something far more dreadful? CERN, established in 1954, is regarded as one of the most reputable research institutions, with 23 member nations and thousands of scientists collaborating as a hub for innovation. The LHC is its flagship undertaking, but only one component of an extensive system of accelerators and experiments. Envision a racetrack, not for horses or automobiles, but for subatomic particles in a time-based race against the clock. The LHC accelerates protons to speeds close to the speed of light, sending them into collisions that imitate the universe's energy at the time of the Big Bang. These collisions create temperatures 1,000,000 times more intense than the sun's core. The protons are guided by thousands of magnets, while intricate cooling systems maintain temperatures colder than outer space itself for the beams inside. At 4 points around the accelerator ring, the LHC is designed to collide particles. These areas correspond to 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a distinct purpose, exploring various aspects of particles. Together, they are like enormous cameras in physics, capturing images of these collisions. Scientists then sort through the debris, searching for evidence of the elusive Higgs boson, also known as the God particle, and other phenomena that provide clues about the fundamental building blocks of the universe. By studying the microcosm, we learn more about the macrocosm. However, each discovery brings new questions, and with each new inquiry, new challenges arise. The LHC is not simply a scientific instrument. It exemplifies humanity's curiosity, innovation, and unwavering pursuit of knowledge to comprehend the fundamental factors that shape our universe. Yet, as we test its limits, we must also consider the existential and ethical concerns that emerge. What are the dangers of probing the unknown? Could our search for understanding inadvertently unleash forces we cannot control? In CERN's halls, where the boundaries of human comprehension are constantly pushed, a new revelation has emerged. Brian Cox, a seasoned scientist, former CERN researcher, and authority in the particle physics world, recently made an announcement that has left a haunting impact. Cox's words resonate with both fascination and fear. The Large Hadron Collider at CERN aims to recreate a miniature Big Bang. That's correct, a miniature version of the very event that birthed our universe. The physicist continued to enumerate the ramifications of this objective, highlighting the LHC's remarkable potential for discovery. This includes its capacity to unlock the secrets of the Higgs boson and a mysterious substance known as dark matter, which constitutes a substantial portion of the universe. Imagine wielding the power to conjure the universe's very essence. It's a tempting possibility, but a dangerous one. The miniature Big Bang is not merely a theoretical concept, but an observable reality at the LHC. The temperatures, pressures, and raw energy mimic the conditions at the beginning of time, the birth of existence itself. Yet, with such power comes responsibility and a looming question. What happens if something goes wrong? In fact, something terribly wrong has occurred in the past. In 1978, Anatoly Bugorsky, a Russian physicist, suffered an incident that would forever alter his life. While working at the U-70 synchrotron at the Institute of High-Energy Physics in Russia, a malfunction caused his head to enter the direct path of a proton beam. The beam, with unimaginable force, entered through the back of his skull and exited through his nose. Bugorsky's experience was unprecedented. He saw a flash, brighter than 1,000 suns, but felt no pain. The beam burned a trail of destruction through bone and tissue. Yet he remained conscious and even attempted to walk to the clinic for treatment. The consequences were both fascinating and horrifying. The beam's path led to localized tissue death, resulting in partial facial paralysis and the loss of hearing in one ear. Remarkably, Bogorsky's intellectual capabilities remained unaltered, and he continued his work in science. This incident is not merely an individual tragedy, but a cautionary example that highlights the enormous power and potential dangers of particle accelerators. Accelerators like the LHC are not to be underestimated. The potential for unanticipated reactions and the manipulation of the fabric of space and time are not science fiction, but real concerns expressed by some in the scientific community. One of the most compelling and alarming issues associated with the LHC's experiments is the potential to create a miniature black hole. A black hole is a region of space-time with such intense gravity that even light cannot escape. These cosmic vacuum cleaners consume stars and lurk in the shadows of our universe. The concept that such an entity could be created by the LHC, even on a microscopic scale, is shocking to both laypeople and professionals alike. Could this black hole expand, swallowing the Earth out of control despite the fact that CERN researchers have reassured that any new black hole would be unstable and almost disappear? The mere possibility has immediately sparked arguments, anxieties, and awe. Given our authority, it is essential to comprehend how the LHC might produce a black hole, which is related to the fundamentals of particle mechanics accelerators that activate when protons are smashed together at a rate close to light speed. The amount of energy released is so great that it alters the very fabric of space-time. Imagine a tightly stretched trampoline, and after that, a substantial weight is placed on it. The fabric is flexible, and if the weight is sufficient, it could result in a depression so severe that anything in its vicinity would be sucked into it, which is a simple illustration of what might occur in the world at the LHC. In quantum physics, the guidelines for universes are beautiful, as well as bizarre. There is a theory that additional dimensions may conceal within. If these dimensions are real, the collisions of the LHC could use them, creating a funnel of gravitation that creates a tiny black hole. This mysterious motion of particles has even attracted the attention of some notable scientists, especially the late Stephen Hawking. In his book, he warned of a situation in which the Higgs boson might become unstable when energy is at very high levels. This instability may result in a cosmic event of catastrophic vacuum decomposition that would not only endanger Earth but also the universe as a whole. The highly regarded British cosmologist and astrophysicist Sir Martin also expressed his worries regarding the experiments carried out at CERN. In his book on the prospects for the future of humanity, he investigated the potential dangers pertaining to particle accelerator experiments, including those carried out at CERN. The words were more than just words of caution. They were infused with an existential tinge of trepidation. He described the worst-case scenario, where a disastrous experiment might create a state known as vacuum instability, which could, in theory, cause a phase change that would penetrate the fabric of space-time, resulting in a cosmic calamity that has the potential to engulf the entire universe. Reza's worries were not confined to theoretical reflections. He assigned these catastrophic, albeit minor, results a probability. However, he argued that even a minuscule chance should give us cause for concern, as the stakes are impossibly high and the margin for error is non-existent. The scientists at CERN have determined the likelihood of the experiments and examined the theories that support the safety of the LHC, Brian Cox included. Recognizing the significance of responsible investigation and the worries and fears pertaining to the LHC's activities, he stressed that strict safety measures, extensive procedures, and checks ensure the LHC's operations are carried out with the highest level of care. Cox reassured that the involved energies are well within what the Earth naturally comes into contact with, and the potential for the formation of a stable black hole is extremely low. Even if one were created, Scientists predict that it would be so fragile and small that it would disappear in a flurry of energy, a phenomenon that Stephen Hawking predicted would be known as Hawking radiation, a fleeting glimpse of cosmic wonder. Some have extended their speculation to include the notion that the experiments of the LHC might open a door to another dimension or universe. Despite the fact that the scientific community has identified this idea as speculative, it has captured many people's imagination and evolved into fascination, fear, and even folklore, describing a world beyond ours. Could we accidentally activate forces or entities that we are unable to comprehend? The concept of opening a door to hell has even generated sensation in a variety of media, contributing to the blaze of uncertainty about what this idea means in the context of scientific investigation. The parallel dimension idea is not new in physics. String theory, a major potential for a single theory of everything, suggests that additional dimensions, rather than the conventional 3 of space and 1 of time, are compressed or hidden from public view. But they could theoretically be accessed or exposed in extreme circumstances. Imagine the LHC as a key to the cosmos, gaining entry through locked doors. Since the beginning, when protons collide at energies never before seen, collisions achieved on Earth could theoretically create vibrations or ripples that reverberate through these higher dimensional spaces. This could be the gateway to a different realm, perhaps accidentally opening a portal that leads not only to another dimension, but further into something darker. The CERN LHC could be more than just an endeavor of a scientific nature. It could, in some people's minds, be a doorway to the unknown. These worries go beyond the speculative aspects of the ongoing debate regarding the risks and ethics of scientific research. Just as humanity confronts the results of technological innovations in AI and biotechnology, it requires us to be ready for the unanticipated effects of tampering with the fabric of reality itself. As the LHC performs its work, figuring out the mysteries of the universe, we must maintain our alertness and be aware of the immense obligation that comes with such power. We may be able to open doors that ought to have been kept closed. Only time will tell.